Hello everyone, and it's been a while that I haven't uploaded a YouTube video, so I would like to apologize about it because I had some important priorities to do last week. So let's go back now in this second part of our test 5, if I'm correct. Is it test 5? Let me check. Yeah, test 5 of right triangle trigonometry. So now let's continue in answering these problems. So in this problem, we find the given acute angle in a right triangle. All right, so let's find the given acute angle here. So the given acute angle here is on the top. So what does it mean that if the given acute angle, or at least the angle that we're referring to, is on the top? So what happens is that the vertical side or the height of the right triangle, this would be your adjacent. And on the other hand, the base would become your opposite. Now, so since we're looking for the, what do you call this one, the given acute angle in the given figure, so what are we going to do? So, first and foremost, again, we need to know what our given sides are. Like, is there a hypotenuse? Is there adjacent or opposite? So, just like what we did here, I first locate uh, which one of them is an adjacent and the other is opposite, right? Then, after that, after I know the given, I must select at least one trigonometric ratio where it has the given sides. So here I have a given adjacent side, which is 16, and a given opposite side, which is 16. So what would be the trigonometric ratio that could be useful in terms of getting this acute angle? So what I can use is tangent theta. Why? Because you see, tangent theta is equivalent to the ratio of opposite to adjacent. All right. So here we can substitute our opposite and adjacent. So we have 16 all over 16. All right. Our opposite here is 16. Our adjacent here is 16. And 16 divided by 16 is simply 1. So we can have tangent theta as 1. Then, since we're looking for the angle, what we can do is we will use an inverse trigonometric function. And that depends on what trigonometric function you use. So since we use tangent theta, so that implies that we are going to use inverse trigonometric function on both sides. So that means we will have arctangent of arctangent theta. Oh, wait. No. Wait. I'm making it complicated. Sorry. Basically, as I was saying, since we use tangent theta, that means we're going to use inverse tangent theta. So basically, just put the tangent here, okay, and leave the theta alone. So we will have theta is equal to tangent. Then put like a negative 1 here. But just like what I explained before, this is not negative 1. It looks like 1, but it is not a negative 1. Just like how you represent an inverse function, here, this is a common representation of function, right? But if you're going to represent the inverse of this function, we will have f, and then there's like a negative 1 here, then x. This is how we say this I mean the way how we can pronounce or describe this is f inverse of x. So the thing is, this one is not negative 1, but it looks like 1. Okay? So going back, yes, we put like a negative 1 here, but again, it doesn't look like a but again, look like negative 1, but it's not a negative 1. Okay? Then open parenthesis 1, then close parenthesis. That's it, right? Or you can use instead arc, then tangent, then 1, right? Either way, both of them are correct. But I would rather use this for simplicity. So we can use our calculator to get our answer. So, where was it? Let me just get my calculator in my phone. So arctangent of 1 is exactly 45 degrees. So the answer here is 45 degrees. And we're good to go. Okay, we're good to go. That's our answer for this second figure. Now, how about this one? Now, if you're going to take a look this figure, this is just similar as our second figure where we have a given angle on the top, you know. So, since we have a given acute angle on the top, that means that this one, the vertical side of the right triangle, is your adjacent, and here on the horizontal side, that is your opposite. All right. And here, since we have a given length of these diagonal side, which is 205 centimeters, this is your hypotenuse. All right. Remember, hypotenuse is the longest side of your right triangle, and commonly it looks like a diagonal side, which is this one. Right. Now, if you're going to take a look, okay, the first step is to know the parts of the right triangle, right? So we have adjacent, opposite, hypotenuse. Now, if you're going to take a look closely, we only have adjacent and hypotenuse only. So that leads us to the second question, or sorry, second step. Find at least one trigonometric ratio where it has adjacent and hypotenuse. All right? Because again, remember, when we solved in the second figure, the first step is we need to know the parts. Second, we will use at least one trigonometric ratio where it has these given parts. So if we have these given parts, adjacent and hypotenuse, so what trigonometric ratio has adjacent and hypotenuse? So we can use cosine theta, all right? Because remember that cosine theta is equivalent to adjacent all over hypotenuse, right? Adjacent all over hypotenuse. Now, we can now actually substitute here. So cosine theta, actually, since it is at the vertex D, I mean it's at the corner D, uh we can just simply substitute this theta as letter D because the theta is located at the vertex D or at the corner D, okay? Then we can now substitute the other. So we have 166 centimeters all over your H, 205 centimeters. All right. Now, question is, can we simplify this? Let me take a look if we can. If not, we're just gonna leave it that way. All right. Let me just see. Okay, so it's not um uh basically we can simplify it, so we can just leave it that leave it that be. And what we can do is we can just cancel the units since we have centimeters above and below, so we can just remove it that way. Now, since we have cosine D is equal to 166 all over 205, so and our goal is to find the angle D. So what we're going to do is we're going to use inverse trigonometric function. So since we use cosine as our trigonometric function, so what we're going to do is we just simply bring cosine in front, let D be alone. So D is equal to cosine, then put like a negative 1 here, but it doesn't mean that it is a negative 1. All right, this represent inverse function of cosine. All right, so cosine, then open parenthesis 166 all over 205 and close parenthesis. That's it. All right, so this is arc cosine of 166 all over 205. So let's get the angle arc cosine or inverse cosine rather. Actually, our cosine, inverse cosine, they're just the same. I mean, they're just the same, right? Okay, so arc cosine of 166 divided by 205. So, according to my calculator, at two decimal places, the answer is 35.93 degrees, right? So your angle D is 35.93 degrees. Okay, so that's for the angle D. But here, we have actually like a sub question or like a second problem here in this figure that after finding angle of D, what is angle G? So basically, if we found the angle here at the D, how about at the G? Okay, like what is angle G? Okay, so this one is already easy. Why? So first and foremost, let's put all like no 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 never mind. Scratch that. Sorry, scratch that. I so let's go back. Yeah, it's easy to find the angle of G by how, if you're asking me. So there's like a lesson in geometry that if you're going to get the sum of all interior angles or SIA, okay, again, SIA means sum of all interior angles. Wait, let me just put it here. Okay, there you go. That's it. Is it visible? Yeah. The sum of all interior angles of a right triangle or any triangle is 180 degrees. What does that mean? Meaning that if you're going to add the corners of your right triangle, like angle D plus angle F plus angle G, it is equivalent to 180 degrees. So we have angle D plus angle F plus angle G is equal to 180 degrees. Here we can substitute our values. So our angle D is 35.93 degrees. Our angle F is exactly 90 degrees. Plus angle G, which is the one that we're going to look for, then 180 degrees on the right. Now take a look. See, we all have we all have given values except for one, which is angle G. So with that, that's already easy for us to find the value of angle G. So what we're going to do now is to find angle G. First, let's combine 35.93 degrees and 90 degrees together. 35.93 plus 90. We have 125 plus 93 degrees, right, is equal to 180. Then we just simply transpose this 125 to the right so that we can combine it with 180. So 180 minus 125.93 degrees. So we have so we have exactly 54.07 degrees. And that's the answer for your angle G. That's it, right? So that is how we got the answer for your last figure in the second problem. All right. Now we will proceed to D. I think this is the last problem. Now here, our goal is to find all the missing sides and angles. Now let's take a look. So let's find first the missing ones. Like, yeah, like the ones that are not present. So we have the side of AB, which is the vertical side, and the angle A. So what are we going to do? Let's start first with the easy one. Like, how do we get the easy ones? So the easy one here is getting angle A. we will apply what we learned here, what we apply here in the last problem, last figure on the second problem, which is the sum of all interior angles of a right triangle is 180 degrees. So therefore, here, we can apply it here. So remember that, again, the sum of all interior angles of the right triangle is 180 degrees. So basically, if you're going to add all the angles in the right triangle, like angle A plus angle B plus angle C, your answer would be 180 degrees. Now, angle A is not given. Angle B, however, is given, which is 90 degrees. It's here. Then for angle C, we have 24.5 degrees. All right. So with that, we can find our angle A easily. All right. Because since angle A is the only variable in this equation as the missing, so this is easy for us to find the value for angle A. So let us combine 90 and 24. So 90 plus 24.5. Mm. Mm. We have 114.5. That's it. It's equal to 180 degrees. Then we will combine this one to the 180. We will have angle A is equal to 180 degrees minus 114.5 degrees. So if we're going to get the exact answer here, this will give you exactly 65.5 degrees. And that's the answer. That's our first answer. We're not done yet. Okay? This is for angle A. All right? This is for angle A. Let me just put angle A on the left side of the equation. So once again, this is 65.5 degrees. Okay, so we're just gonna put it here. All right? Now, we found angle A, okay, which is 65.5 degrees. Now, how about the side AB, or basically the vertical side of the right triangle? So here, there are like many ways for you to get the answer, right? There are many ways. One of it is using the trigonometric ratio for us to find the vertical side of the right triangle, which is AB, or we can just simply what do you call this one? Actually, yeah, trigonometric ratio. Yes, we can use that. Yeah, and then there's like another method of it, which is finding the components of your diagonal side. All right. If you don't understand what I mean by finding components, basically that if you have a given hypotenuse and then you're looking for the horizontal and the vertical side, and you have a given acute angle, all you need to do is that for you to get the horizontal component, just multiply the hypotenuse by cosine theta, where the where the given theta is the given angle here, and for the vertical y, we will just multiply the hypotenuse by sine theta. So that's basically what I mean. All right. So you can use what do you call this one? A trigonometric ratio for you to find the side vertically, or you can just simply use the second method, which is getting the horizontal component of your hypotenuse. So I will just use both, okay, so that you understand me. I'll just use both, okay? So let's just try first the one with the trigonometric ratio, okay? So first and foremost, our referred angle that I can use is angle C. All right. I will be using this as my given acute angle. So if this is my given acute angle, what happens to the sides of the right triangle? All right. So first, our hypotenuse is still 36.87 units. our BC or the base of the right triangle, this is adjacent. And this question mark, the one we're looking for, is opposite. All right. So if we use angle C, this is the result. Our adjacent is on the bottom and our opposite is on the vertical side. Now, the thing is, we will use at least one trigonometric ratio where we can find the opposite side. So we have two choices here. We can either use, we can either use, what's that again? Sine theta, because sine theta is equivalent to opposite all over hypotenuse, or we can use tangent theta, which is equivalent to opposite all over adjacent. So either way, it's still correct as long as you use the correct formula for this problem, and some of it are these two. Now, let's pick which one. So for me, I can pick sine theta. All right. So for sine theta, we have opposite and hypotenuse. So because of that, I can clearly substitute my theta as sine C is equal to your opposite, which is the one we're looking for, all over your hypotenuse, which is 36.87. All right. And remember that your C is 24. Oh, wait. Your C is 24.5 degrees. Is equal to the opposite all over 36.87 degrees. Right, there we go. Now that we have two given terms, oh, wait. Sorry. 36.87. That's it. So now that we have two given terms and only one missing variable, which is your opposite, we can we can find your opposite by putting 36.87 beside sine. So we will have 36.87 degrees times, why is it that I put degrees in here? Sorry, times sine of 24.5 degrees is equal to opposite. Is equal to opposite. So here we have 36.87 times sine of 24.5. Yes. So here at two decimal places, our answer would be 15.29. That is our opposite, right? And that is our answer. Okay, you can try using tangent theta. Now let's try to apply the second method. So in here, remember that in second method, all we need to do is we just simply find the horizontal and vertical component of your diagonal line. So let's take a look at this problem. We have a, let's take a look. Wait. Let me just erase this. Okay. So here in this right triangle, we have a diagonal side of 36.87, right? That's our diagonal line. Now, if you're going to take a look, we have a horizontal component of it, which is 33.55 degrees. And remember that in a diagonal line, wait, is it visible? Right, in a diagonal line, and you're looking for its horizontal component, all you need to do is just you multiply the hypotenuse by cosine theta, where the theta given is on the bottom, right? So if we have a given what it calls one given acute angle of 24.5 degrees, and you have a hypotenuse here, you can get uh 33.55 units by using this formula. All right. Now, the thing is, we're not focusing on the horizontal side, but we're going to focus on each vertical side. So this is what we are focusing on. Okay. So in the vertical side, basically, all we need to do is we multiply the hypotenuse by sine theta. So to find this one, all we need to do is multiply the hypotenuse by sine of 24.5 degrees. So in this case, uh, we will have 36.87 times sine of, what's that again? 24.5 degrees. And the answer is still the same. So approximately, this is 15.29. And yay, that's it. That is our uh, answer for our vertical side of the right triangle. And we're done. That's it. We're done for our test 5. And the next test, that would be our last test, which is basically real life applications of right triangle trigonometry. And that will be all.